Good afternoon, sir.
Good afternoon, ma'am. We can start.
Shall we start, sir?
Yes, ma'am.
Okay, sir. So due to some technical glitch, my video is not working today. A very good afternoon to everyone. We are still waiting for the participants to join, but they'll keep on joining. But we'll start with the session today. I take this opportunity to welcome you all to the day 8th of this faculty development program. So Dr. Pooja was here with us yesterday as well, and we had a wonderful session on machine learning. So, ma'am, I think the audience already is very familiar with you and has really enjoyed the session yesterday. It was both starting from the basics and then to the advanced. It was overall a complete session. So we welcome you again, ma'am, and it's a privilege of having you here today.
Thank you so much, Dr. Surbi. I think we should start the session.
Sure, ma'am.
All right, I'll start sharing my screen.
Yes, ma'am. Your slides are visible, ma'am.
So today's session is on not machine learning, deep learning with MATLAB. And we intend to cover a lot of subtopics under this title. We'll start with basics of deep learning and neural network. We'll see how neural network works, what are the major components. Then we'll see how we can build and train deep learning models, what are the approaches to do that. And what we'll also focus on one typical deep learning model, that is CNN, convolutional neural network, so that we have a better understanding of working of deep learning models. We'll also talk about transfer learning, and then we'll move to MATLAB and we'll try to implement a deep learning model based upon transfer learning approach. So we'll start with this. Before I start, I hope that participants completed the course from MathWorks yesterday, what we were doing there. All right, so we already know what is machine learning. Now, deep learning is actually a branch, or you can say a subset of a machine learning itself. So in machine learning, we have a lot of algorithms like KNN, naive-based supervised learning. We have unsupervised learning algorithms. We have reinforcement learning. So in machine learning, there is something known as neural networks also, artificial neural networks. So when we talk about neural networks, deep learning only works on neural networks. So it does not, it has no other algorithm working under this heading, deep learning. So deep learning is a subset of machine learning. It will use neural networks only, but not the simple neural networks or shallow neural networks. It will use or implement quite complex neural structures and try to mimic the behavior of human brain itself. So there will be multiple layers of processing in deep learning, and we require a lot of data to process deep learning. For our deep learning model to learn something, we actually need a lot of data. So this is how we represent. You will find this kind of an image quite often if you will search for what is AI, ML, and deep learning. So both AI, both machine learning and deep learning are branch of or subset of AI, and deep learning typically works on neural networks and it comes under machine learning. It is more specialized version, you can say. So what are the basics of deep learning and neural networks? So deep learning basically is used to because it actually accelerates, it exceeds the computation power, and it can work on larger data sets very easily. It enables self-learning. So in machine learning, if you remember, the machine learning process started with data collection, then there was data pre-processing, then in the pre-processing, we tried to fetch the features also. In deep learning, that whole step is eliminated. You do not need feature extraction from the data or feature selection from the data. The deep learning model itself will do the needful to extract the hidden pattern from the data. So that means in deep learning model, you can directly input the raw data, right? This is how the structure looks like. So when we talk about neural networks, there is usually a layer of neurons. Neuron is the basic component of any neural network. We'll talk about what neuron is. So there is an input layer, there is an output layer. Whatever are your inputs you feed, based upon the size of input, the number of neurons are decided in the input layer based upon what is expected. Let's suppose you're classifying mails into spam and non-spam. You can have one input, you can have two inputs, spam or not spam, right? And then in between these two layers, there are hidden layers. When the hidden layers are n number of hidden layers and the structure is very complex, then it becomes deep neural network. All right, I thought this might be of interest. What is the difference between deep learning and machine learning? As you can see here, in machine learning, we had data, we manually extracted features, and then we put that cleaned data or extracted features to the model, and then the model was able to classify or predict, right? But in deep learning, we have data, and then we implement it on, we directly send this data to the model. Inside the model, there are so many hidden layers that in every next layer, every other hidden layer, it tries to extract more complex features. So this is how the hidden layers of the deep learning network work. First, it will extract the simpler features, then more complex, and by the time it goes to the final computation, it has all the complex structures within the data as features extracted, and then it starts predicting. So this manual feature extraction is not needed in deep learning. All right. So this is the architecture behind deep learning. As I said, neural network's basic component is a neuron. So what is a neuron? Neuron is nothing but and it is like a neural cell of the brain. And this is how it works. So there will be multiple inputs. Multiple inputs are entering as an input. Then every input has a weight assigned to that. Based upon the weight, I mean, the input value is multiplied with the weight, and then all the inputs are aggregated. They are added up. There is a bias also. And then whatever is the weighted sum, why we call it weighted sum? Because weight is the multiplied along with the input. So the weighted sum of the inputs, that value is entered into the activation function. Now, activation function itself is a mathematical formula, right? Now, based upon what type of activation function is used, the output, and based upon the value of this weighted sum, the output may get triggered or may not get triggered. This is how the inputs are transferred to the right? So there are basically three major steps. One, each input is multiplied with the weight, then all weighted inputs are added together, and then that weighted sum is used as an input for the activation function. Now, activation function here plays a very important role. With the help of activation function, what happens? This input sum is actually optimized and that is converted into output for prediction, right? So it depends upon activation functions. We'll talk about various activation functions are there and where nowadays those are used. When it's I mean the research started on neural networks, the very basic activation function used was a threshold value. So let's suppose in the activation function the threshold value was 0.5 and this weighted sum is 0.4, so output will not be generated, right? So what will happen? Again, the weights will be changed for the inputs. So the learning of this neuron is changing the weights so that the output is as expected. And once you get the expected output, those weights are the final values of the weights for each input. And then we say, okay, let's suppose x1 has weight w1, this is fixed. If x1 has weight w1, then the output is generated. So this is how learning happens. There are a lot of steps in between. We'll talk as we'll move ahead in the session today. So this is important, that weights are being adjusted during the training, right? So these are all the, not all, but most of the activation functions which are used. So basically activation function does what? It includes or introduces non-linearity into the network so that network can learn, right? So there are some of the important activation functions are on the screen, like sigmoid. Sigmoid is used, the formula is also mentioned. Sigmoid is used basically for binary classification. It is used in output layer. Then there is TANH, there is ReLU function, there is leaky ReLU, there is softmax. Softmax is used in multi classification in output layer. Most of the times ReLU we will be using when we will implement convolution network. Usually it is used in hidden layers of CNN. We have ELU, we have swish, we have GELU. There are a lot of activation functions, and you can try when you are learning deep learning, or when you are trying to learn it, you can try different activation functions on your network and you can see what are the outcomes, right? But lot of, as I've told, lot of research has been done, so you can just pick and find out which activation function will work best for your particular problem, right? So what is a shallow neural network? Shallow neural network is one which has only 3 layers: one input layer, one hidden layer, and one output layer. So inputs have bias. All inputs are connected to all inputs means all neurons in the input layer are connected to all the neurons in the next layer, which is hidden layer, and then again all hidden layer neurons are connected to the output layer. Right? This is simple. This is, you can say this is fully connected network right now on the screen, because every neuron is connected to every other neuron in the next layer. It is fully connected neural network, you can also say that, but this is the shallow one. Shallow one because there is only one hidden layer. Let's see how neural networks, what we have just talked. This is just 2-minute video. Let's hear this out, what it is saying.
Neural networks are algorithms that are based on the way the brain works. They can build predictive models by learning the patterns in historical data. Neural networks are made up of small, interconnected processing elements. These elements are called nodes. Each node processes a small part of the task. The most common type of neural network is called a multilayer perceptron. In a multilayer perceptron, The nodes are organized in layers. The first layer is called the input layer. The outermost layer is termed the output layer. Between these two come one or more layers. These are called hidden layers. The input layer receives the values of the independent variables as input. The nodes of the hidden layer take their inputs from the input layer, process it, and pass it on to the nodes of the output layer. This is what happens within a node. A node receives information from multiple nodes of the previous layer. These are multiplied by unique weights and added together with a small value called a bias. This total is processed by a function called the activation function and leaves the node as output. This process proceeds till information reaches the output layer and leaves it as a prediction for the dependent variable. The network then compares the prediction with the actual value of the dependent variable. If these do not match, it adjusts all the weights in the network and repeats the process. These iterations get repeated till the neural network is able to produce accurate predictions for most.
So I don't know from where I picked this video, but this particular video, it is a channel, I guess. It has a lot of very good videos, so I kept it one so that you can use them later on for your references also.
Neural networks are algorithms.
I don't want
Please
to. Okay, so basically, what is a neural network? We have already talked. So mathematically, it is just adding, multiplying, and then adding, and then giving the output, the weighted sum, to the activation function. Now, in deep neural network, what happens? We have more than one hidden layer, right? So deep learning will have lot of hidden layers, right? Now, again, how many hidden layers will be there? It depends upon the problem you are trying to solve, and of course, the size of the data. Now, how does a training of a neuron actually, there is a mistake here. How does a neuron or neural network gets trained? So there are 2-3 steps in between. So we understand that from input layer to the next layer, what happens? There is a weighted sum, and then there is an activation function. In every neuron, there is that. Every neuron of every hidden layer, there will be an activation function. Inputs are added up, multiplied with their weight. Now, what is happening? Once all this sum is transferred till the output layer, so that means input data is traveling towards the end or the output of the network. This is known as forward propagation, right? Now, what happens after this forward propagation happens? The output is generated. Now, output is compared with the input. Now, if there is an error, that error calculation is done. Error calculation means the predicted output and the actual output, which it was supposed to be, that is calculated. That difference is calculated, and then that difference is propagated back to the every layer, and based upon that difference, the weights of the previous layers are changed. This is what is happening. We'll see one example also in the upcoming slides. We'll try to do that one by one also, right? So there is forward propagation, error calculation, back propagation. In back propagation, what is happening? Weights are being adjusted, and this whole process keeps going on until what? Until the error at the end, error between or the difference between predicted and actual value is minimized. Till then, it keeps on working. So in machine learning or deep learning language, we say that many epochs have been happening in the while training, right? So this is what happens when you train a model. So how does back propagation work? Let's suppose we have a network architecture where we have two inputs in the input layer, X1 and X2. We have hidden layer neuron networks, two, H2 and H1, and the activation function is ReLU. And the output layer has one neuron, Y, and in the output layer, the activation function is sigmoid, right? So this is what my network is. Now what will happen? First is forward propagation. In forward propagation, what we will do? First, we will initialize the weight. So you can randomly take some value. Then you will calculate the hidden layers activation functions based upon this ReLU's formula. So ReLU's formula will work on the weighted sum of all these, right? Then we calculate the output layers activation based upon this sigmoid. Then loss comparison will be done. You can use mean square error or binary cross entropy. There are different ways of calculating loss, right? So we call it as loss function. Then back propagation will happen. In back propagation, I'm not sure if you are aware of the concepts of gradient. So gradient descent is used to minimize the loss. So we compute the gradient of the loss with respect to the output layer base, right? Then we compute the gradient of the loss with respect to the hidden layer. And then we update the weight. This is what is happening. So let's consider we had the value of X1 and X2 as 0.5 and 0.2. And the initial weights we have taken, W1, W2 will be the weights for X1, X2 in the input layer. W3, W4 are the hidden layer weights. In the hidden layer, how many we have? 2. And Y is the neuron for that. And W5, why W6 is also there? Okay, we'll see. W5 is the layer weight of the W5 and 6 are the weight for the output layer. And let's suppose the target should be 1, right? Now what will happen in the first step, forward propagation, will implement ReLU activation function on the weighted sum. So what is the weight? 0.4 multiplied by input 0.5 plus minus 0.1 multiplied by 0.2, right? Then this ReLU 1 activation function for hidden layer 1 is calculated. Then hidden layer 2 is calculated same way. Okay, this is there is hidden layer 2. This is second hidden layer, right? So this is calculated, and then we will calculate the Y value of the output. In output, what we have to do? We have sigmoid function, right? Now in sigmoid function, we'll implement sigmoid, and same weighted sum will be implemented. Now what is the weight? Weight is 0.7, and the output coming from hidden layer 1 is 0.8. Let me draw this and I'll show you what is happening actually. This color. There was supposed to be shapes. Oh, there are no shapes now. Okay, let's say it like this. Input 1, input 2. This is the input layer. Then I have hidden layer. Hidden layer 1, neuron, hidden layers, neuron 2. And then we have the output layer with one sigmoid function. Why? So what is happening? This is going here. So what is the weight? And this is also going here. This is going here. And this is also going here. Now see what are the weights. We have weight here as 0.4. For I1. For I2, we have minus 0.1. So minus 0.1 is also going here at H1. I will write it here also. Minus 0.1. So at this H1, what is happening? Minus 0.1 multiplied by the value of I1. Sorry, I2. I2 is 0.2. So from here, 0.2 multiplied by minus 0.1 is going here. From here, 0.5 multiplied by 0.4 is coming here. All will be added and then ReLU will be implemented here. Same is going here and ReLU will be implemented here. And after that, in Y, we have sigmoid. So what is happening? Here also, what is the weight of H1 and H2, right? So what is the weight of H1? We have for H1, we have 0.2, okay, initial weight was 0.4. Then we had 0.3. 0.2, sorry. 0.7 and 0.1. One value is extra written here. This is what is here, right? Two extra values are written. So now what is happening? No, it is correct. Here it is different 0.3 for weight 2. And here it is 0.2. Correct. It was right. So there for this it is 0.4. Then we have let me do it again. For I1 we have 0.4. For I2 for H1 we have minus 0.1. I got confused. And for I1 and H2 we have 0.3. For I2 and H2, this connection, the weight is 0.2. Now it is correct. And from H1 to Y1, it is 0.7. We have taken different. And from here, it is minus 0.3, right? So now the value of I1 is 0.5. Value of I2 is 0.2. So now the calculations are being done. So what is the what all inputs are coming at H1? 0.5 multiplied by 0.4 plus 0.2 multiplied by minus 0.1. And what is coming at H2 hidden layer second neuron? 0.5 multiplied by 0.3 plus 0.2 multiplied by 0.2. Now what is the total after ReLU function is implemented? Let's suppose it is 0.01. So the value, the input coming from H1 to next layer hidden will be 0.8. That will be multiplied by 0.7. And from H2, the calculated weight is 0.9. That will be multiplied by 0.3. And sigmoid will be implemented on this total addition. So the output is 0.0. Now we have, what is the output? After sigmoid, the output generated is 0.517. Is it the actual output? No. So how do we know? We have to calculate the loss function. So this is how we calculate the loss function. Half 1 by 2, not half 1 by 2, target value minus the predicted value. to the square of that, right? So this is the way, this is the error function, right? Now what we will do, we will take this error back to the hidden layer so that this weight is changed. All right. So what we will do, we will calculate the gradient. Gradient is partial differential of loss by the value predicted, right? So we will check that. We will we'll compute the gradient loss. Now this gradient loss, because for H1 sigmoid was used, right? We will change the weight. This is how we will change the weight, right? So updated weight will be calculated by this partial differential of loss with respect to the weight, that particular weight. Whatever weight we are going to change, that multiplied by the learning rate. Learning rate is a value which will be multiplied by this. So let's suppose it is 0.1 or 0.7. Then whatever was the previous weight, that minus this will be generated the updated weight. So this happens, it goes back till this weight. This is how back propagation, this is how training happens actually, not just back propagation, right? All right. So now we will see I'll have to do this one by one. All right. Now, this was what the working of the basic network. Now, how we can build or train a deep learning model? There are two approaches. First is you can train a deep learning model from the scratch. So when you're doing that, what you need to assemble a large labeled data set. We are talking about classification problem. You design a neurons architecture, network architecture that will learn this data. This is very good approach when there is no pre-existing models or for a new or specialized application you are developing it, right? It has a primary drawback. The drawback is that you require a lot of data so that the training can be done with a high performance, and it consumes less time also, right? So this is what is training from the scratch. So we will see CNN and how CNN convolution neural network is one type of deep neural network. We'll talk about this. Usually it is used for image classification or image recognition object. It works on images actually, right? Typically same. So this is the block of, you can say block diagram of CNN. It has few components, like there will be an input layer, then there will be a convolution layer, there is a pooling layer, there is a fully connected neural network, and the output layer. Now, what is the function of convolution layer? Convolution layer does what? It performs the convolution process on the image. If you are aware of deep digital image processing, convolution is a very basic, not very basic, convolution is an operation which we usually perform on images pixel by pixel, right? So the same same process is being implemented in convolution layer, and in convolution layer there are a lot of hidden layers, and by implementing convolution filters, after every hidden layer new features are being extracted, right? So it starts from the basic features like dots or edges, then the dots connected, edges connected with other edges, corners and all, and ultimately by the end of this convolution layer we will have whole complex features ready or extracted for us. So it will produce a feature map as an output, right? Now there will be activation function also in this also, and usually we use ReLU in this convolution layer. Then there is a pooling layer. After convolution layer, we'll talk how convolution works and how pooling works with an example again. So in pooling layer, what we do? This feature map is usually of high, you can say, dimension. So we reduce its dimension and we pick the important features from the feature map, and then we move those features to the next layer. There are basically two techniques for pooling. There are many techniques, but most commonly used are max pooling and average pooling. And then there is, ahead of that is a fully connected neural network. So this fully connected neural network will now actually take all the features generated, right, as an input layer, and then there will be hidden layers, fully connected, it will generate the output. It is like a traditional neural network which we have discussed, right? Now, what is a convolution layer? In convolution layer, there is very important thing which is known as filter. So on every image, a filter is being processed, or it runs as for the convolution. It generates the convolution of filter and the image. This is how it extracts the features from that image, right? I'll tell you what is stride, and padding is sometimes the images which are input to start the convolution process or control the output size of the image. We add extra zeros around the image. That is known as padding, right? I will tell you what is stride. So let's suppose we have a grayscale image 3 by 3. The pixel values are this 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this is my kernel. This is my filter. Filter is also 3 by 3, but it has the value 1, 1, minus 1, and minus 1. Now what we will do in convolution, we'll place this filter over the left top corner, and one by one we'll process each pixel. In processing, what we will do, we will multiply each element, corresponding element of the pixel, with the filter, and then we'll add up all the 3 by 3 values, right? Now what is sliding? Stride. Next, after first pixel, we will move to next pixel and then next pixel, and we'll go on till the end. Stride means, let's suppose stride is of 2. Then after first, we will jump to the second pixel. We will not use this pixel while applying the filter, right? So now let's see what will happen. Now we are convoluting. This star is a convolution operator. Actually, we are convoluting input image with the filter. So what will be the result? Result will be this 1 multiplied, a dot is missing here. This 1 multiplied by 0 plus 2 multiplied by 1 plus 3 multiplied by 0 plus 4 multiplied by 1, and so on. So the output will be minus 3, right? So this is minus 3. Then we will move to, after that we will move to second. So this 0 will come here, 1 will come here. There are no padding, so these values will not be used. This is how it will work, right? So ultimately we will have this gray image converted to minus 303. Pixel values have changed now, right? Now once this has happened, this happens on the whole image. The next step is to use the pooling. Pooling will do what? We will try to reduce the feature map and will preserve the important features. How do we do that? We use either max pooling or average pooling. Let's suppose this was my image. Now it is again a filtering process. In max pooling, we are now using 2 by 2 filter and stride of 2. So what we will do, we'll divide this whole feature map. Now we are working on feature map, not the image itself. Now we will divide it into 2 by 2 because the filter is 2 by 2. And then in each region, we will pick the maximum value. If we pick the maximum value, that is max pool. If we pick the average value, that becomes the average pooling, right? So -3 is not, okay, minus will not work. So this is what is the feature map. Now see, from 3 by 3, it has become now 2 by 2. So the dimension has reduced. But still, this max pooling gives results in a 2D feature map. Now, very important step, which is known as flattening, is done. So in flattening, after pooling, we do flattening. Flattening will convert the 2D feature into 1D array. You can write a function in MATLAB like this, right? Simple colon will convert 2D into 1D array. Then you can use it on your pooled output. Our pooled output is -3, 3, -6, 6. And the output will be -3, 3, -6, 6. So now my 2D image has been converted into 1D. Why do we need to convert it into 1D? Because after pooling, our data has to move to the input layer of the fully connected neural network, right? So we need 1D data for that. So based upon this feature, now we will input this to the fully connected neural network, and same thing will happen: activation, forward propagation, back propagation. It will learn and it will give the. Now these are the basic steps for coding deep learning into MATLAB. First thing you need MATLAB. There is a toolbox, deep learning toolbox, right? You load the data. Yesterday we understood how to load the data. So right now we are using this MNIST data. MNIST data has a lot of images, small images of 28 by 28 pixel of handwritten numbers. This is how the data is. This data is freely available. .mat form is also available. If you want to do something with Python, it is available with CSV file and all those. And this data is very easily available. Now, load mat, whatever your file name, will load the data. If you want to display some of the features, you can use for loop and it will start showing you the images, because this is 28 by 28 images. That is why we have reshaped the image show into 28 by 28, right? Then we need to, so first step was you need a deep learning toolbox. You need to, first step is actually loading and preparing the data. Second step is you need to define the neural network. How do you define? This is how you define the neural network. So our neural network will have some input layer. There is an input layer. How can you have an input layer? This is the function image input layer. Okay. Then inside this, you define the size of the input layer. Corresponding to our data, it is 28 by 28. So we have considered 28, 28, 1 as the input layer. Then what will be the second layer? Second layer is a convolution 2D layer, right? So we have used convolution 2D layer. The size, the padding, if required. Then we do normalization also. The batch normalization is done to normalize everything. Then ReLU activation function is used here. This is this ReLU activation function for the convolution layer is happening, right? Then we need max pooling 2D layer. So max pooling 2D layer is used. For average pooling, the function will be, name will be different. And after that, we need fully connected layer. And in fully connected layer, we need last output layer softmax. And then at the end, we will have the softmax layer. We'll use the activation function as softmax in fully connected layer. And then we will have the final output layer, the classification layer. So this is how you define your layers when you create the neural network from the scratch. All the definitions, what they are doing is written here. Then you define the training options. Training options tells what will be the initial learning rate, right? what can be the batch size, how many epochs you want, right? All these things you can mention in your training options. Whether I have written it as an options, and the this inbuilt function training options is used. Then you train the network and evaluate the network. For training the network, you use train network on which you want to use, what is the features set, what is the labels, what layers, what is your network, right? We used, see here, our network was named as layers, right? So which network is to be used and what are the training options? You have said set all, right? You can assign one variable to this. This is, you have started the training. Once the training will take time. Once the training is done, now you start prediction, right? So for predicting, you need this. You can do classify. You can use classify function on this trained model, and there shall be some test data, right? So test data can also be imported separately, like we did yesterday, right? And then you can check the accuracy. This is how, these are the basic steps how you can build CNN. We have tried to build using from the scratch, right? This is one approach of building or training a deep learning model. Now we will see what is the next approach. Next approach is transfer learning. Now what is this transfer learning? Transfer learning means you transfer learning. So there was an existing model which was trained. The model is learned model which was trained on some data. Now you are reusing that training, that learning into your problem. So in deep learning, for example, image classification or computer vision or audio processing, transfer learning is usually employed. So what is it? You use the pre-trained model. There are a lot of pre-trained models available. You use a pre-trained model, then you fine-tune it as per your data or problem. So you begin with the model which is already trained on a large data set. For example, Google Net is there, SqueezeNet is there for image classification. Then you get that model adapted on your new data set with different classes. This is how you do. You will have to do some adjustments and then you can use it. The advantage of using this is that it requires less data and training time is also less because your model has already learned a lot of features, right? This is how transfer learning works. So you load the pre-trained network. These are the early layers that learned low-level features already, right? Then you train them. You load it with your thousands of classes, whatever, right? I will show you from where I have picked it. Then you will understand why it is written thousands of classes. Then you replace the final layer. See here, the final layer was as per the task specific features from the previously trained network. Now you change the final layers so that it learns features of your classes, your data, right? So it will learn faster. Then you do what? Then you train the network on your training images, right? And after that you predict, you see the accuracy. If accuracy is less, you again go on the training, and this process is an iterative process. You keep doing that until the final losses error is less. This is how you build or train deep learning model using transfer learning. I'm not going through this video. You can check it later on. So we'll go to deep learning toolbox on MathWorks. If you do not have created the account yesterday, do it like this, and we will do it now. There is this cheat sheet which I wanted you to see. You'll find such cheat sheets available on mathworks.com. You can get for machine learning, for deep learning. If you want to do something with audios, you can check it, get it for that also. And if you will see it, all basic things are mentioned on this cheat sheet, right? So what is CNN? What are the layers? What are other deep learning networks like LSTM, right? How they work, how to import layers, what are the pre-trained models available, AlexNet is there, VGG19, all these are there, right? How you can use them. What are the training options available? You can have maximum epochs, mini batch size, initialize, all these training options are mentioned. What is their purpose also? I mean, it is a quick reference. How to validate, how to predict, classify, how to visualize your progress or progress of the training model, how to improve accuracy. So there are hyper parameters. So you can use hyper parameter tuning to increase or improve the accuracy. So what is the function to use that? So such cheat sheets are very useful and are a quick reference for this. This is this. I hope my screen is available, visible to you, right? Oh, yes. All right. I'm not showing you this. This is the ebook which from where I have picked that image. So this is an ebook. You can also download it from MathWorks. It has practical examples of using deep learning with MATLAB. A lot of examples are up there. This is how to train model from the scratch, which we did, which I showed you on MNIST data using convolution neural network. We'll do this example only today. How to access the data, how to train it, everything is mentioned. This is also a quick reference. How to configure your neural network, CNN, how to train it, how to plot, everything is mentioned in this. Okay, this is second example of transfer learning, right? So how to do, I have included this link also in the presentation. So this is how you do the transfer learning. I picked it from here only, the image. So you import the pre-trained network. How do you import it? Then how do you test the data? All these things are and easy steps. You can easily do it, right? So let's do the transfer learning thing only today. So this is the course which I want you to open. I will skip all this introduction part and we'll start with pre-training networks. Transfer learning. Okay, let me see from here. Let's start this module. I'll give you 4-5 minutes. Meanwhile, you can also start it. If there are any questions, you can ask. It will take a while. Due to weather, the internet is slow today. Yeah. Okay, this is very basic how to input image. Okay, let's do it from here only. So view image. How can we view images in MATLAB? Simple IM read. IM is for image. Read is the function. I'll quickly do this. Image 1 is equal to read. File name is file01. .png. No, .jpg. JPG is the this is my image. Image was here. Image is not showing as image. Image in MATLAB is converted into array. So this is the pixel values of that array. Size of the image is this 273 by 273 multiplied by 3 means it is colored 3 values, red, green, blue, right? Using imshow we can check, we can see how does it look. I think next task is, yeah, so we will say imshow is a function image 1. Now we will see what does this image look like. See, this is what the image is. Okay. So right now we will use pre-trained network on simple images. Now we will see what is a pre-trained network. I'm not going through this because we know what is a pre-trained network. Now here we will be using Google Net pre-trained deep neural network. We will use it. So this is task 1. We need to load this pre-trained network first. Okay, so we are saying deep net is equal to simple name of the network. Done. So see here, what are the properties? It has this many layers, this many connections, input layer, this, that, everything is loaded. Now we already have an image. Now using this pre-trained network, we will try to classify what this image is. Okay, we will try to predict the subject of this input image. Image is this one, right? So we will use classify function. Classify function on what? We will use deepnet. Use the model deepnet on what? On image 1. And we are saving the prediction in prediction 1. It is saying the category is C sure. So did we train any network? No. But using a pre-trained network, we could easily classify our input image very easily, right? This is, so the training was not required. We did not spend time on training, right? We'll quickly do this and then we'll move up to our MNIST data. We'll go to the next. Now we will do same for image 2 and image 3. This is prediction 2 for image 2. Then we will have prediction 3 for image 3. Image 2 is this. There is a cat. Image 3 is this, which is a sofa. Let's see how Google Net, our deep network, will identify that. It is saying to this cat, it is saying it is a mountain dog and this is a studio couch. Not bad, right? So it could do that. Now we will see. So this we have done on one images, right? Not on the whole data set. Okay, I'm skipping further practice. I'm skipping this also because we have the basic understanding of deep learning and CNN also. We know what are the layers now. Now we will start the CNN. This. Now we will check. We will examine the layers in Google Net one by one. See, this is how we created our network from scratch. Input, convolution, pooling layer, then ReLU, then fully connected, then softmax, then output layer, right? This is how we did. Now, so now what we will do, we'll examine the properties of these layers to determine what form of images takes this net takes as an input and what classes it returns as output. So we will extract the layers of our deep net. How can we extract the layers? We will say our network name dot layers. L is capital. And then we will save it into variable ly. Now we will see all these layers. See, we have data layer. I don't know how to pull this. So if you can see here, see, we have data layer, convolution, then ReLU, then pool 1, then convolution 2, then pooling, then all this is happening. And at the end, the output layer. All these are in between the Google network. And if you will scroll it from here, you will see what exactly is happening. There is input layer, then 2D convolution, ReLU, max pool. Cross-channel normalization, then 2D layer. So in convolution network, we understood there were multiple convolution layers, right? So all these are convolutions happening. Then max pooling, then convolution, then max pooling. And at the end, we have fully connected layer, softmax, and out. Got it? This is what we have it. So how do we examine our layers? We examine by using layer itself. Now we'll see. We'll extract the input layer now. Okay. So in layer is equal to first layer, right? So which one is my first layer? Is input layer. Ly 1. Oh, this. This is my input layer. What is the size of the input layer? Data augmentation is used or not? All the properties of input layer we can see. So there are different functions, like you can check the input size. In next task, you can extract the output layer. Then you can see the classes. Let's see the classes. It will not move to the next. Let me just finish it. In size is equal to in layer dot input size. So S was capital. This is the input layer's input size. We'll finish this and then we'll move ahead. Let's check the output here. Like we did. Out layer. End. Right. This is my output layers property. Output size is 1000, right? Now we will see what all classes are used. We'll say the name is out layer dot classes. Thousand by one categories. All these are the categories. There are 1000 categories used in Google Maps. You can check the categories: French, goldfish, great white shark, and so on, right? So you can check. So why do we need to check a pre-existing layer network? Because we need to understand how much we need to change it later on, right? Whether we can use it as it is or not for our purpose. Let's check the predictions now. Now we will see what is the prediction score, the accuracy and all, right? So we'll use the classification function with the pre-trained network to predict the subject of this. So we will say predict is equal to classify. Our network here name is different. Now our network name is net, not deep net. Okay. So we will say net image img. Now image is saved in image only, right? So this is the prediction, but we also need the score. What is the score? So we will save the score in scores. All the prediction scores is written here. You will see that for all 1000 categories, what was the score, right? I think we can open it here. and you can check the values, right? All right. Now it is saying create the bar chart for the course. All right, so we will create bar chart on course. For the task 3 and how can we do that? Here is the bar chart. So here it is one bar only. Here. So from that, we will now extract the significant scores. How can we do that? We'll do it like this with the high score, greater than this, right? So we will say, create a logical array with the name high score. High scores is equal to scores greater than zero point zero one. I don't know if it will work or not. So we have logical array. Now in this, we will create a bar with threshold value. This bar scores. No. Scores. Do not worry if you're not understanding. I just want to move ahead so that we can finish this off, and we'll go to I just pick the solution, add it here, and then we'll go to the next. We're just labeling. Now we have labeled it as high scores. What was the high score? Lakeside, promontory, sandbar, seashore, right? All right. So this was how we managed one image or single image, right? On the pre-trained data. Now we will try to create a data store. Once we'll create the data store, then we will use the data store on our pre-trained model, right? So we already have a pre-trained model GoogleNet loaded. Now we will use this command, image data store, right? So we will use this command, image data store, and we will create an image data store as variable imds, and then we will refer to all the value images of .jpg extension. from the current folder, right? So this is how we are creating it. This is the current folder, and there is an error. Okay. Yes. Now we have all the files from this which are of extension JPG, right? We have created an image data store. Now we will use the files property of this to extract the file names of the image, right? And then we'll store this in the variable fname. So fname is equal to imds dot files, right? So we had image data store. From image data store, now we have file names here. You can see file 01, 02, 03.jpg. All are JPG only. I can show you like this. All files. So there are 12 files with JPG extension. Now we will read the images, right? And we will import the images using read function. Right now we will read one image out of that file, not all. So we will have img is equal to read image from where? From our data store. Im data store. Which file? 7th. Right? So this is my image, which is the 7th file, 7th image, 7th file in my image data store. Now we will do what? We will classify. So this one is separate. We will use it for testing. For all the remaining images, we will use it to classify. The same Google net, right? So we will do predictions, classify. My Google's pre-trained network's name is net, and IMDS is my data store. So earlier we used one single image. Now we are using data store to train and see all the 12 categories for all this. Seashore, Earth, starlets, all has been predicted. So same function, but now we will use image store. We use image store to predict. I will skip this. Yeah. We'll start from here. Now we will prepare the images for use as input. So we will check the size of the image, because now we'll have to train our pre-existing model with our images, right? So we need to verify whether our images are ready or not. So we will check it and we will prepare our images. So I am trying to check the size of the image. So as you can see, the size is 1096 by 822 pixels multiplied by 3. Every pixel has 3 values. One for red, one for green, one for blue. Red, green, blue. Right? Now we will check the size of the input layer of our Google, our pre-existing Google network. But how we did that earlier? Input size is equal to net dot input size. First layers. We do not have net. First, we have to import it. We have not imported. That. Oh my years. Now it will work. So we imported, we loaded pre-existing network. We extracted the layers, first layer, and then we are checking the size. Size is 244 by 244 into 3. What was our image size? 1096, 822, 3. Right? So let's see how we will prepare our images. We will resize our image to this pre-existing network's input layer size. So we will use im resize on our image. What should be the size? 244 comma 244, right? And we are saving it in img again. And then we need to display the image in show img. Correct. In the size is not oh. My keyboard is not working well. All right. Now my image is smaller in size, right? And the size will 244 by 3. Done correctly? We did same. bug. Why it is showing? Let me just copy the solution. It happens many times. This is task 3. We did same, right? I don't know why it is not doing that. Okay, colon was not there. So when we put colon after the command, the output is not generated for that particular command on the console. Yeah, now it will work. That. So what we did, we checked the size of our images, then we checked the size of the input layer of the pre-existing network, deep neural network, and then we changed our image size. Right? This is what we did. Now we did this for one image. Now we will do image resize for whole images in the whole data store. Right? So we already have this. Now we need to create a data store. We did this earlier also. IMDS is equal to image data store. It's done. Now we will use augmented image data store function to change the size of all the images. How we will do that? Let's see. Like this. Augmented data store is this. What will be the size? 244, 244. Done. Still it is showing this. Okay, I used 244. It was 224. That is the error. Not an issue. Now we will submit. The size was supposed to be 224. Now we will classify. Now we'll see what is the difference. Predictions is equal to classify using net, the augmented data store. Now these are the outputs. So what we have learned, we have checked the input size of our predefined data. We checked the input size of our input data set. We changed it, we mapped it as equal, and then we implemented it. Now this was only about size. Sometimes you need to pre-process the color of the data as well, your own data, right? So usually images are processed on grayscale, right? So now we will see how we will convert our images into grayscale images. So montage is the function to see the images into grayscale. IMDS. So on all the images of our data store, we have implemented montage, and now see all images are in grayscale, right? Now we can convert them into, so these images were 3D array, right? There was a value of RGB, right? Now we will create augmented image data store, and we will pre-process the images to have size of 3D like that, 2 to 4 by 2 to 4 by 3, right? We'll say augmented data set is equal to same function two to four, and see here we are using, I can take this back here. What we are using? Color processing. So we are converting grayscale to RGB. It will automatically include the 3 into the image for all 3 values. Now we will classify. Predicts is equal to classify what Usenet on augmented data set. If you compare all, whatever processing we are doing on the images before, sending them as an input to our pre-trained data, you will see the values have changed here. Okay. Excuse me. So you can have your images in the subfolder also. Let's suppose you have face recognition images for happy face, sad face, this, so those are in folders. Now how to work on folders? So we can create subfolders in while creating the data store itself. How we can do that? By using same function, image data store, and then we'll put the folder name. And what all images we need to do? You need to have this only. So we have created a data store. From the folder called flowers. We forgot to include this. Now it will. So now we have created data store from a folder, not from the images directly. You can resize them as we did earlier. Now same process of resetting, resizing. Let me just take it from solution. Now it is saying run classification for 15 images from the folder. Okay, fine. Number of observations are 15 only. So how can we do classify on this new augmented data? Predictions is equal to classify. That is my predefined pre-trained network, and this is my images. See the prediction: Daisy, 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 cartoon, Daisy, Daisy, Big Bang. Now we'll perform transfer learning again. I'm skipping all this components also. This is a typical flow. This will go through. So you have training data, you have modified network, you have training algorithm options, you train your network, then you evaluate the trained network. If accuracy is less, then you again train your data or maybe modify the network or change the training algorithm option. This is what we have to do. Let's do that. First, we will label images in our data store. As of now, our images are not labeled, right? This is what our data store. There are images in the folder flower. And it has subfolders. Subfolder names are of the names of the flowers. So name of the folder can be used as the name of the label for that observation. Let's see how we can do that. So we have flowers data. Flowers name is equal to this folders dot label, right? So what we need to do is design the code at the top of this creates this data store which contains all the images from this path it has taken. Now recreate this using folder names as the image label. Let's do it from here. So we have to recreate our data store, image data store using our names and include is equal to group. And we need labels also. So for that we will include label source is equal to this. Folder names. Hope this will work. Not from here. Let me check what issue we have facing. Name, same thing we have done. Why is it not working? Let's check our code. Okay, this is not the name. It should work. So now we have labels as Daisy, 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 and so on. Now we have flower and their labels. How can we extract the labels? Already done. Now we'll split our data. Our data is ready. We have labels also. We have pre-processed it also. We know we will be using GoogleNet as pre-trained network. Now we will split our data into training and testing, right? So we will use, usually people use 70-30 or 80-20 ratio. Here it is saying us to use 60%, 60-40 ratio. So which function we will use? We will use split function, right? Split each label. We need two data sets. One is flower train. Next will be flower test. Right? And our data store is flower data store. I is not there. And P is the value. 0 to 1. So we will say 0.6. This is done. So small function split each label. Which data store, how much portion, and variables for train and test, right? Now we will use randomize flag so that the data is first shuffled and then randomly picks data points from train and for train and testing. So we'll simply use randomize. And now it is saying selection be 80%. So we will do it like this. So change the portion value 0.6 to 0.8 for 80%. I'm skipping this. Now we need to create two data stores. With an absolute value of equal to 50. 500. Okay. So same function, instead of percentile, we are using 50, that's it. 500, sorry. Just showing how in different ways you can split data into training and testing. So our data is prepared. We have training separate data, testing separate data. Now what is the next step? We have pre-trained model also. Oh, it is saying we can augment data, training data also. CNN I'm skipping. Side. Now we will modify our network layers. We modify the layers of predefined network so that it can the second step. Remember this. This. As of now, we have done this. Now we will train our model, change the layers. So when you will have your own deep learning toolbox, there you can also create, design your own networks, right? This is we are adding, we are now moving to designing part, right? See, there are inbuilt networks, pre-trained networks. We'll pick and then we will design it according to our requirement. Okay. This is the starter page. So first our pre-trained network is what? This one, right? Google Net. So we will open this. Done. See, these are all the layers. This is the design. Then we'll move to data, we'll move to training. I think we have enough time. We'll be able to complete this. Now it is saying add fully connected layer from convolution and fully connected section. In the properties panel, set output size to 5. So here is my this. Where is my fully connected? We have to change what? The output layer, right? This is my fully connected network layer. Here is the property. And what we need to do? We need to put the output size to be 5. Okay, done. You can zoom into this to see the whole network. Now next is replace the last fully connected layer of the network with the new layer. We have this new layer. We have to open this somehow. This is classification layer, softmax layer, fully connected layer. This with, we have to replace it. Okay, it is called this. We have to replace it with this. Duplicate, copy, cut, fit to view, export. No, we are not ready to export. It's getting added, but where? This is the overview. Okay. I'm not here. To replace it, you can delete the existing layer, that then add a connection to your new layer. That connection you can drag and okay. This is the layer. I'm not even able to see where it is going. So it's what it is. We added this. Okay, it's done. Yes, Dr. Deku. We have added and we have changed it to 5. This is done. We have replaced it. Mhm. Why it is not happening? You did that, right? Is anybody else trying? To me, it is showing. Okay, let's start from here. Is there any more? Wait, not able to see the output. Not connected. It is not connected. Deleted. Okay, let's start it again. So we are including this here. Size is 5. This connection should go there. Delete the existing base. Okay, this is the sequence, activation, tooling, resizing. This is simply saying delete it, delete on the view, and then connect the new layer. New layer is, can anybody see this? Now, all right, this is done. Almost there, hang in. We are almost there. Now create a classification from output section of this layer. And replace the existing output. All right. So we will delete. We will not delete. We will first create, otherwise it will pick error. Classification layer. Done. This is done. Okay, so we have modified the output layer of pre-trained network. Now we'll set the training options. Okay, once we'll set the training options, then our system will be ready. We'll create a variable options is equal to, we'll use training option and we will use the same gradient descent optimizer. Okay, here we are adding optimizers only. There are different optimizers, like Adam is also used. So now we will change the learning rate in this optimization. Okay, how we can choose? We will say, not here, sorry. This. And our property is initial learning rate is equal to 0.001. This is done. I'm skipping this. How to perform this? What are mini batches? Using GPU. Can we continue or you will be able to do that? Yes or no? So we have done, we have pre-processed it, we have done. Now we will check the training loss, right? We need to plot it. This is our training loss. Now we'll classify and we'll see how much is our what are the predictions, right? We'll use classify on what is this? How predicts classify our net on size image data set. See all the classifications. And the last is you can investigate the test performance, whether it was done correctly or not. Same thing, you will check the labels, predicted labels, the actual labels, find the difference and so on. I think we'll end up here. Otherwise it will take a lot of time. again. So you can check, you can create the confusion matrix also later on. Do this. So our purpose was to understand how pre-trained networks can be used in deep learning. So that we have done. We have already used pre-trained network GoogleNet. We prepared the data, we replaced the layers, and then we trained it. Now prediction is pending, that you people can do it on your own, I guess. If there are any questions, you can ask, otherwise I'll end up here only. That is all from my side, and really sorry for taking extra 10 minutes.
Yes, thank you, ma'am, for your nice presentation. Dear participant, if you have any question, you can unmute your mic and ask your query. You are allowed to unmute your mic.
I think today's session was really heavy. We all have gone.
Yes.
There are a lot of things to cover.
Yeah, deep learning always take too much time.
Yeah, it takes time.
Yeah.
But I'm happy we were able to do
Dr.
something.
D.A. Dico, you can ask your question. You have raised your hand. Unmute your mic, please. Dr. D.A. Dico. Any question, please? Yeah.
Yes, thank you, Prof. My own is not a question per se because I got lost so many times because of the network issues. I want to request that the link for the further reading and information should be sent to us, maybe via the chat box. Then I would also like if we can get the video immediately after now, so that one can take some time to do additional work, because it's really very heavy, and for some of us who were not able to connect throughout the session, we might have to go back and do some personal work, because we are getting in contact with this directly for the first time with such a deep interaction. So that's my request, so that the videos can get to us early and we can do some revision. Thank you. Thank you, Prof.
No problems, Dr. Diko. I'll be sharing the presentations with Math Tech Thinking Foundation. Surely you will receive all the presentation. All the links are inside the presentation itself.
Okay. Thank you.
Any more question, please?
Thank you, Param sir. Thank you, MATLAB.
Dear participant, we have shared already with you one Google Drive link and all the content which are being presented during the sessions we are uploading there. Secondly, the recordings of each session is available on Mathematic Thinking Foundation YouTube channel. Along with the participant who are registered on the platform, all the recordings will be uploaded there. Due to some technical issue, we are not able to right now upload there. But we have shared the playlist of all the entire sessions, which will be available on the single link. Okay, so whenever you need in the future, and some of the participants are not able to join during the session, they contacting us after the session or in the evening due to their busy schedule. So everything which are presented during the session are available for you. And still, if you have any kind of question or prompt, please always feel free to contact us. We will, and our team will surely support you and will help you. Now, over to you, Dr. Surbhi or Dr. Shivam. Shivam Prata is there. Okay, so I think I have to conclude the session. So thank you once again, dear professor, for your nice presentation, and valuable content has been presented during the session. And I hope that all the participants who are attending your session surely will be very informative, very knowledgeable, and very helpful, who are interested to work on this domain in machine learning and deep learning. The questions also has been discussed from the participant side. Yes, ma'am, you want to say something?
No, I
What
was
I'm
just
doing.
thanking you.
Yeah.
That's what I'm doing. I'm also in your
Always
class.
feel free to contact us. Ma'am is also very friendly, and I'm sure she will help you. If anyone want to collaborate with us, always welcome.
Thank you.
Thank you. Thank you to all. Now it is time to end the session. Tomorrow we will start the session at the same time. So I request all of you, please the session at least 10 minutes before the commencement. Thank you to all. And email address Pooja has shared. You can check chat box if you need to contact her. Yes, please.
All right, sir, I'm leaving then.
Yeah. So the feedback form and the quiz will be shared in the chat box in the WhatsApp group. Okay, you will check within 2 minutes. Thank you to all. Now